The situation being one is there two atoms are at a large distance and no interaction between electrons and nuclei. The molecular wave function can be represented as phi is equal to phi is molecular wave function is equal to atomic wave function of hydrogen atom A, atomic wave function of hydrogen atom B. When this equation is solved, it is observed that the total energy of the system is not different from the atomic system. There is no difference between total energy of the system and the atomic system, and thus can be concluded that there is no interaction between atoms. Hence, bond is not formed. Next situation is there. Situation 2. The two hydrogen atoms are present at a distance. They just touch each other. Look here. There are two hydrogen atoms and just touch each other. And in this case, the molecular wave function in this case is also given by the equation. This is pi molecular wave function. This is atomic wave hydrogen atom A and hydrogen atom B. When the equation is solved, when this equation was solved, it was observed that total energy of the system is somewhat less than the atomic system. This shows that there is somewhat attraction between the atoms and energy of the system is less, well, which means that some interaction is present among the system, and the bonding energy corresponding to this wave function calculated as a wave function of internuclear distance is only 25 kilojoule per mole, and this energy 25 kilojoule per mole was calculated in this case. Situation number 3. The two hydrogen atoms are close together so that this orbital overlap each other. And here the situation is that overlapping here take place so that the orbitals overlap each other. This overlapping may result in the exchange of electrons. When overlapping takes place, then electrons will exchange. The molecular wave function in this case may be represented by means of the following two equations. Phi 1 psi HAA dot psi HBB. Phi 2 is equal to H psi HAB psi HBB. This situation represents that covalent bond formation due to the exchange of electrons. Here, exchange of electron. In this case, look here, hydrogen atom A, but electron B of second atom transfer here, exchange take place. Here, atom B and electron of first atom is. This situation represents the covalent bond formation due to the exchange of electrons. Electrons exchange, sharing of electrons, phi covalent. So we can write here phi covalent is equal to phi 1 plus phi 2. The bonding energy calculated for phi covalent is 301 kilojoule per mole. In this situation, phi covalent energy is 301 kilojoule. The difference 301 minus 25 here, this is equal to 276 kilojoule per mole. Is called exchange energy as it results from the exchange of electrons between the two bonded atoms. When the theoretical value of bond energy, and theoretical value is 301 but experimental value is 435 kilojoule. When these two energies are compared, it is observed that calculated energy is less than the experimental value. And now situation number 3. Situation number 3 is the difference between calculated and experimental value is somewhat accounted by considering ionic bond formation. That is, the electron from one atom to another atom is transferred, and the second hydrogen atom. The molecular wave function describing ionic bond is represented as follows: phi ionic psi HAAB. Here electron of A and electron of second atom is transferred here B, and psi HB plus psi HA and psi HB. Electron of A is transferred to B. Here transfer of electron take place here because electron is gained here. So negative ion is formed, HA negative ion plus HB positive ion. This will lose, and plus H positive ion, this will lose and this will gain. So it gets negative charge. The calculated bond energy for ionic is 96 kilojoule per mole. Phi is equal to phi covalent plus phi ionic is equal to 301 plus 96. This 96 is equal to 397 kilojoule per mole. This calculated bond energy is still less than the experimental value. The difference is explained due to the presence of screening effect and the polarization of atomic orbitals. Now we will give examples. Number 1 is fluorine molecule. The combination of two fluorine atoms, atomic number 9, results in the formation of fluorine. Look here, the formation of fluorine molecule in the form of diagram can be represented as this 2pz orbital of one fluorine atom, 2pz other fluorine atom. This is linear combination of atomic orbitals take place and fluorine molecule is formed. Second is oxygen molecule. Atomic number is 8 And here sharing of two electron pair take place and double bond is formed between hydrogen and oxygen atoms has two single unpaired electrons. And look here, this is here parallel overlapping take place. One is sigma bond and one is pi bond. Pi bond, two pi regions are present, and parallel overlapping in case of sigma bond, direct or head-to-head overlapping takes place. It appears from the above diagram that the oxygen atom molecule has a double bond consisting of one sigma one pi bond. Structure of oxygen molecule based on the valence bond theory shows that presence of unpaired electrons which should make oxygen molecule diamagnetic. Actually, oxygen molecule is paramagnetic with two unpaired electrons. Therefore, with two unpaired electrons. Therefore, valence bond theory fails to explain the structure of oxygen molecule. This is drawback of this theory. Number third, example water molecule, in which directional character of covalent bond is shown. Covalent bonds are directed in character. This can be explained by taking an example of water molecule. Water is formed by the combination of two hydrogen atoms, one oxygen atom. Electronic configuration of hydrogen atom is 1, oxygen atom is 8, and the overlapping of partially filled orbitals of oxygen with one s orbital of hydrogen atom may be represented as follows. The two hydrogen atoms and the one s orbital will take place overlap with the two p orbital and z orbital of the oxygen atom. And here HOH bond is found. Angle should be 90 degree. HO bonds in the water molecule are polar. The partial positive charges present on the hydrogen atom repel each other. As a result of this repulsion, bond angle is increased from 90 degree to 104 degree, which is actual bond angle of water molecule. Okay, hope it will be clear to you all students. Okay, thank you.